Assalamualaikum everyone, this is Abu Chaudhary and welcome to our chemistry class. Today we are going to cover some more topics from chapter 2.06. So let's not delay anymore and let's begin. So I would request everyone to please write the name of the chapter and the number of the chapter, chapter 2.06, covalent substances. In the previous class we have covered the properties of molecular solids and we have known the reasons of it. And we have also seen or known some substances and their melting points. But today I am going to write the details of that thing. But you guys do not need to memorize this thing, just you guys need to revise this thing. So let me give a short lecture or a short review on the previous thing. So molecules are made of non-metal atoms joined by strong covalent bonds. Molecules are made of non-metal atoms joined by strong covalent bonds. For example, oxygen, water, ammonia. These all are molecules. These all are molecules, and these all molecules are made up of non-metal atoms. For example, oxygen. Oxygen is made up of two oxygen atoms, and oxygen is a gas and it's not a metal. Water is made up of two atoms of hydrogen and one atom of oxygen, and both hydrogen and oxygen are gas. Ammonia is made up of one atom of nitrogen and three atoms of hydrogen, NH3. Ammonia is equals to NH3. So there is one atom of nitrogen and three atoms of hydrogen. And ammonium, NH4, there is one atom of nitrogen and four atoms of hydrogen. And see, in both ammonia and ammonium, nitrogen and hydrogen both are gases. There are no metal atoms present in the molecules. So we can say that molecules are made up of non-metal atoms joined by strong covalent bonds. This is the answer applicable, or this is answer for question which have only 1 mark. For example, what is molecule or what a molecule? You are given only 1 mark. So you just need to write molecules are made of non-metal atoms joined by strong covalent bonds, full stop. If it's only given 1 mark, and if it's given 2 marks, you need to give example. Molecules are made of non-metal atoms joined by strong covalent bond, full stop. For example, give at least 2 examples. For example, colon, oxygen, give bracket and write O2, then give comma, then write water, then give bracket H2O, etc. You can give full stop there, or you can write 2 more examples of molecules. But for 2 marks, I would say just write the previous definition and give 2 examples. That's all. Now let's come to the point that what is or what are molecular solids. Iodine is a very good example. Of molecular solid. Each iodine molecule contains 2 atoms held together by strong covalent bond. Iodine is a very good example of molecular solid. Each iodine molecule contains 2 atoms held together by strong covalent bond. This is a very simple thing which I have explained in the previous class. I am also explaining today, and it is that iodine is one of the very good example of when we are going to talk about molecular solids. It's the most common example and the most used example, and it is also a very good example. That's why I have said that iodine is a very good example of a molecular solid. Each iodine molecule contains 2 atoms. Each iodine molecules contain 2 atoms and these two atoms are held together, and these two atoms are held together by strong covalent bond, and these two atoms are held together by strong covalent bond, which means that the bond between these two atoms are very difficult to overcome, to break, or the forces of attraction between the bonds, the forces of attraction between the atoms of this ion of this molecule, the forces of attraction, the force of attraction between the molecule, between the atoms, the forces of attraction between the atoms of the molecule is very high. So it's very difficult, and that's why it's difficult to break the force of attraction or break the bond. That's why it has a strong covalent bond. It is held together by a strong covalent bond. Now we have known that what is a molecule and what is molecular solid. Now we are going to learn about what is molecular solid. Molecular solids are solids that are essentially collections of molecules held together by intermolecular forces, IMFs. The molecular solids are solids that are essentially collections of molecules held together by intermolecular forces, IMFs. The solid structure is maintained by IMFs rather than bonds, metallic, covalent, or ionic. Rather than bonds, like metallic, covalent, or ionic, the forces holding solids together are much weaker than for other types of solids. Molecular solid. More কথা হচ্ছে যে এখানে the main thing here we need to know that molecular solids are nothing but a collection of molecules. A collection of molecules is known. A collection of molecules held together by intermolecular forces. When the forces between two atoms is force of attraction, and the forces between two molecules is intermolecular force. So molecules are solids. Molecular solids are none other than a group of molecules held together by intermolecular force. By intermolecular force, IMFs, intermolecular forces. The solid structure is maintained by IMFs rather than bonds, like metallic, covalent, or ionic. We know that there are three types of bonds: metallic, covalent, and ionic. So molecular solids do not have neither of these three bonds. Molecular solids have neither of these three bonds. Instead, they are maintained by the intermolecular forces. The forces holding solids together are much weaker than other types of solids. Means that ionic solids, covalent solids, metallic solids এর তুলনায় এই তিন ধরনের বন্ডিং হওয়ার পর যে সলিডটা হবে, সেই সলিডের যে ফোর্সটা হবে, the forces we will find between the solids of metallic, covalent, and ionic, among these three, or comparing with these three, the molecular solids have a weaker force. The molecular solids have a weaker force comparing to these three bondings. Now let's come to the point, properties of molecular solids. Now come to the point, properties of molecular solids. Molecular solids have low melting and boiling point. Molecular solids have low melting and boiling point. Molecular solids do not conduct electricity. Molecular solids have low melting and boiling point. Molecular solids do not conduct electricity. Now, after that, we are going to know the reason that why molecular solids have low melting and boiling point and why it does not conduct electricity. The first property we have learned is that molecular solids have low melting and boiling point. Now, molecular solids have low melting and boiling point because the forces between the molecules are weak. In fact, many molecular substances melt and boil below room temperature. So, the main reason the molecular solids have low melting and boiling point is that we already know that the molecular solids have weaker forces. The molecular solids have weaker forces compared to the solids of three types of bonds. molecular solids have no melting points compared to the solids of three bonds. So, in fact, many molecular substances melt before room temperature. So, the basic room temperature we hold is at 25 degrees Celsius. So, many molecular solids or many molecular substances melt before the room temperature. For example, like 24 degrees Celsius or 23 or maybe 10 or 20 or at -1 degree Celsius, we don't know. So now we also know that the second property is that molecular solids do not conduct electricity. Now let's find out the reason. Molecular solids do not conduct electricity because molecules are not charged. So substances cannot conduct electricity even when melted. So the main thing is that we have done the covalent bond solids, the ionic we have known that the covalent bond, ionic bond and metallic bond have charges, but the ionic solid, covalent solid and metallic solids have a minimum amount of charge, but the molecular solids do not have any overall charge. Hence, as it does not have any positive or negative charge, it won't carry electricity. So molecular substance cannot conduct electricity even though they are melted. So molecular solids do not conduct electricity because molecules are not charged. So molecular substances cannot conduct electricity even when melted. Full stop. Not all covalent solids are molecular. Short covalent solids molecular final. Not all covalent solids are molecular. There are some covalent solids which are molecular but not all. Now, we have revised some substances. For example, substance number 1, which is hydrogen. The melting point was -259 degrees Celsius. The oxygen, second substance is oxygen, which was -219 degrees Celsius. Water. Here, water which we use in our daily life, which is in our house, or the water we eat is not pure water. Or the water we eat or we use to wash our hands or wash clothes or to shower is not pure water. So the boiling point is 100 degrees Celsius of water, and the melting point of water is 0 degrees Celsius. The pure water is the melting point, and the boiling point of pure water is 0. Melting point is 0 degrees Celsius, which is that pure water ice. When we are forming ice with pure water, the ice will melt at 0 degrees Celsius. And if the water contains some kind of substance, then the ice would take some time, or the temperature will be high. Or low, but not 0 degrees Celsius. And only pure water melts at 0 degrees Celsius, and only pure water boils at 100 degrees Celsius. Now, silicon dioxide silica, which exactly melts at 1610 degrees Celsius, which means that 1610 degrees Celsius. Silicon dioxide melts at exactly 1610 degrees Celsius. Carbon as diamond. The diamond. There are two types of carbon we are using actually there are many types of carbon, but the most two forms of carbon which is diamond, and another one is graphite. These are the two most common forms of carbon we are using in daily life. For example, the carbon which is shaped in diamond, we use it for jewelry, and the graphite, the carbon which is shaped or made in graphite, we use it for pencil nibs. Most of the time. And there are many other uses of graphite and diamond also. So, Clearly, diamond and silica are not molecular solids with a weak lattice. Their melting points are too high. Their melting points are too high for that. They form a giant covalent structure rather than molecules. Clearly, diamond and silica are molecular solids. Clearly, diamond and silica are not molecular solids. As we know that molecular solids have low melting and boiling point, and where silica and diamond both has very high melting point and boiling very high melting point. So it cannot be a molecular solid. Clearly, diamond and silica are not molecular solids with weak lattice. Their melting points are too high for that. They form a giant covalent structures rather than molecules. Let me write this thing as a notes. I hope you guys have remembered. You guys now remember the topics from the last class. Now I'm going to start today's topic. So I hope you guys are seeing that I have written something on the board. So please give a star mark and write note and write this thing below. So those who cannot understand my handwriting clearly, I'm sorry for that. And so let me dictate the thing. Clearly, diamond and silica are not molecular solids with a weak lattice. Full stop. Clearly, diamond and silica are not molecular solids, comma, with a weak lattice. Full stop. Their melting points are too high for that. They form giant covalent structures rather than molecules. Full stop. Clearly, diamond and silica are not molecular solids with a weak lattice. Their points are too high. Their melting points are too high for that. They form giant covalent structure rather than molecules. So I'm keeping it for 2 to 3 more seconds. So those who didn't write it, please write it or take an SS. So now, what is a giant covalent structure? We are going to learn this thing next. So, what is a giant covalent structure? What is a giant covalent structure? A giant covalent structure is a three-dimensional structure of atoms. A giant covalent structure is a three-dimensional structure of atoms that are joined by covalent bonds. A giant covalent structure is a three-dimensional structure of atoms that are joined by covalent bonds. Full stop. What is a covalent bond? What is a giant covalent bond? What is a giant covalent structure? Bond. It's not a bond, it's a structure. What is a giant covalent structure? What is a giant covalent structure? A giant covalent structure is a three-dimensional structure. A giant covalent structure is a three-dimensional structure of atoms that are joined by covalent bonds. Although my drawing is not that much good, but it's understandable or it's relatable enough to make you guys understand that this is approximately how a three-dimensional covalent structure looks like. What does it mean by three-dimensional structure? This is a three-dimensional structure, and it is a giant covalent structure. This is the giant covalent structure. This is how a giant covalent structure looks like. Now later on we are going to learn about allotropes. Now allotropes are different form of same atoms in same state. Allotropes are different form of same element in the same state. Let me write the definition. So this is the definition of allotropes. Allotropes are different forms of same element in same state. Allotropes are different forms of same element in same state. Different forms of same element in same state. So we can think of an example like your twin brother. But the characteristics is, for example, a replica of something, but one is a greater quality and another one is a cheaper quality, different forms. That's how I can actually give an example right now. So for example, graphite, and diamonds are allotropes. Yes. See, graphite, diamonds and graphite are three different forms of carbon. So each item has its different use. Diamond we use mostly for decoration, for jewelry purpose. Graphite is mostly used in the nibs of the pencil, and I really do not know what graphene is used for. Graphene is used for. So these are the three different atoms or three different states of the same atom, carbon. The fundamental atom is carbon, and these are the three different forms of the same element. The same element is carbon in same state, in solid. Graphite is also solid, graphite is solid, and diamond is also solid. So they have the same state. That means that now I can give you a better example. The better example will be that the allotropes are the different forms of the same element in the same state. Let's think of the same element as the same family or the same surname: graphite, graphene, and diamond. Graphite, graphene, and diamond. They have a surname. For example, they are three brothers, and they have a surname of what? XYZ. They have a surname of XYZ. So XYZ is the same element. They have the same surname. So surname equals to same element and same state, which means that they all are human, right? They all are human. Or we can say that they all are of 10-year-old kids. Graphite, graphene, and diamond, they all are 10-year kids with the same surname, or they belong to the same family in different forms. Now there is a twist here, different forms. One is quiet, one is nerd, and another one is extrovert. One is quiet. He doesn't speak much. For example, graphite doesn't speak much. Graphene is someone who studies a lot. In another words, or in a bully word, we can say it as a nerd. For example, graphite is a quiet kid, and graphene is the nerd, and diamond is a bully. So three brothers with three different characteristics. They belong to the same family, and they all are of 10 years old. So let me write the example to make you guys understand better. So as you guys are saying that same element equals to same family, which is equals to graphite G, which means that graphite, graphene, diamond, they belong to the same family, which means that they have the same element, which is carbon. Same state, which means solid state, which I have written same age and different form. Now here is the twist. The different form means that the different characteristics, every person's characteristic differs from one to another. My characteristics won't match with yours, and your one will not match with me. So and in the same way, graphite, for example, graphite is a quiet kid, graphene is a nerd kid, and diamond is a bully one. Diamond is a bully kid. Pardon me for using the word nerd as the student who, or the person who studies more or studies very much, it will be very long. So I beg my pardon for using the bully word nerd I mean no harm to anyone. The person who studies a lot is also very good. The bully one, he or she can be reformed, or he or she can become a good person, and the quiet kid also is a good person. So there is no bad person. Bad is nothing. There is nothing bad. Bad is the absence of good, as darkness is the absence of light. As the same thing, bad is the absence of good. So I beg your pardon again for using the word nerd. So see, graphite, graphene and diamond belong to the same family, XYZ. They have the surname XYZ family. XYZ family, the same state means they are the same age. The age can be 10-year-old, they can be 24-year-old, they can be 76 years old, and different form, which means that graphite is a quiet kid, graphene is a nerd one, and the diamond is a bully kid. Diamond is the bully one. So three giant covalent structures. There are three giant covalent structures. These are a part of three giant covalent structures: graphite, graphene, and diamond. They have the graphite, diamond, and silicon dioxide. Graphite, diamond, three covalent structures. We are going to learn that is graphite, diamond, and silicon dioxide. Graphite, diamond, and silicon dioxide. In the next class, we are going to learn more, but let's keep it till today. আজকের জন্য এতটুকুই থাক। Inshallah, we are going to learn more in the next class. So, Assalamu alaikum everyone.